Okay, here's where we're going to go into working with Phobos to create a URDF for our project. Phobos is a plugin or an add-on for Blender for URDFs. I said that backwards earlier. And you get that by going out, just do a web search on Phobos Blender, and you'll find it. The Git page, download the zip file, unzip the file, and inside you'll find a folder called Phobos inside the Phobos master folder. Zip the Phobos folder somewhere else on your drive, and then do this. I know it's kind of complicated, but you go to Preferences, Add-ons, Install, and then search for your Phobos. I think I put mine in Downloads. It's right here, Phobos Master, but I actually re-zipped this Phobos folder and just put it here. You want this folder zipped, and you'll add that in. I'm not going to do it because I just already installed it. And once you've installed it, be sure you tick the box next to it to make sure that it is enabled. And then you should, when you open your end panel over here, you'll see the properties, and you should see in Object Manager, or your object properties, you should see the new Phobos matrix information, Phobos object information, property information, and model warnings, all right in here. Okay? So, we're going to start by letting Phobos know. First thing I should mention is that my approach to this is going to be as simple as you can make it, and I hope it works. We're going to try it. I want to visualize these 4 levels here with all their components on them as just a big cylinder that moves around. And then we've got the 2 wheels, which are independent of the cylinder, and the 2 casters, which are also independent from the cylinder. So technically it's 1, 2, 3, 4, 5 parts. That's it. Everything else is just sort of fit together. So what I'm going to actually do is select all my components. Hopefully this will work. It crashed before when I did this. And this, and this. Control J to join them together. Okay. Created this whole thing is together now. Whoop, except for the last plate. J. There we go. So now all of this is together. Okay. Move that back into place. Let's set the origin to 3D cursor, and let's name it body. Okay, now I'm hoping this works. When I was testing it earlier, it seemed to be working, but we'll see if it actually works in simulation and that sort of thing. Great. So now we've got, oh, the batteries didn't get picked up either, did it? There we go. Okay, so now all that stuff should be together. So we've got a body, the back caster, the front caster, the wheel left and wheel right, if we were looking at it from this angle. Okay, left, right. Now what we need to do is we need to add a skeleton to this. What it'll do is it'll create a hierarchy. The other thing we need to do is we need to tell Phobos what kind of type each one of these parts are. Right at the moment, the parts that we're looking at are simply are visuals. So in the URDF, it's going to be a visual. So we're going to do this as visual. Do this in the object properties panel over here. Don't use this set Phobos type because it's buggy. If you use set Phobos type, you're going to have to set Phobos type. It'll be undefined, and you have to set it to visual. Okay, but that's not enough. You have to hit A and then unselect for it to take. Okay, and then you can see now it's visual. You can bypass all that just by setting Phobos type right here in the Phobos object information. So you see it's undefined, and we will set it to visual. This is visual, that is visual now. This is undefined, which we'll set to visual. And the back one is undefined, which we'll set also as a visual. There we go. So everything's set. Now what we want to do is we want to create our first link that will be in the URDF. All right. So we're going to do this by create links. Kinematics right here. You see create links. And it created a link. We're going to make sure it's creating the link at the object. We're going to make the visual size 100 so we can see that thing. In fact, let's go a little further. Let's make it 200. This is a big, there we go. And this will be the link body. All right. Very good. We select our link. Oops, there it is. I'm going to, in the bones properties here, there's viewport display. I'm sorry, in the viewport display in for armatures, there's this in front. Click that for each bone you make so you can see it and select it very easily. Okay. Now that bone's created, we're going to define joint, which is right here. Once we do, you see it turns into a different icon. This is the revolute icon, a revolute joint type. We don't want that. For the base, we want a fixed type. Okay? So there we have it. It turns into this little jack-looking thing. Now, this wheel here, we're going to also create link. You see it creates link wheel right up here. This link is going to be different. First of all, let's set its in front over here so we can see it. And define joint, we will define it this time as continuous. Yeah? Okay. Now we'll do the same thing with this one. We will... by the way, that might appear up and down depending on... The only reason this appeared sideways like this instead of up and down like this is because this wheel is oriented... you can see in the item properties it's oriented 90 degrees, so it matched the orientation of the wheel. This one will be sticking up. When I do this one, it'll be wrong. You see, create link. See, it's sticking in this way. And what I really want is for it to be -90, sticking out the other way. Like that. Okay? So there it is. And technically this wheel should be -90 as well. There we go. And this one should be +90, and this should be +90. Good. This whole thing is probably oriented wrong anyway, but we'll fix those things as we go along. So now let's go back to the Phobos menu here. Let's do the in front. Define joint. It'll default to the last one you used, which is continuous. That's what we want. Let's go to the caster here. This is the front caster. And this one will create a link in front. This one is facing forward, but we kind of don't really want that either. Let's set the rotation to 0. Okay. And it doesn't really matter, I guess, for this one, but because this is what we're going to do is we're going to make these particular joints, we're going to make them fixed joints, or fixed joints. Define joint as fixed. And what we're going to do is set the friction on these to nothing, so they'll just glide along the floor in the simulation. All right, and then one last one here. Let's create link. Selected object. Again, we'll get rid of that. We'll do 0. So it's facing, we'll do in front so we can see it. And view, define joint, it will be fixed. Okay. Now we have to pair everything. We have to create a hierarchy. So we have to pair everything to this center joint here. Okay. And the way you do that is very special. It's similar to the way you would do it if you were just doing a regular skeleton, a regular armature in Blender. But you're going to click the one you're going to want to pair to this one. Click, or shift click the link you want to pair to. Control P, and then it's very important, bone relative. When you're pairing the joints together, it has to be bone relative. So we'll come back to this one. Click the joint you want to link. Click what you want to join it to, what link you want to link it to. Control P, bone relative. And you can see over here they're pairing. Okay? And you can see these lines down there that are showing the parent-child relationship. So we do this one, shift click the middle, Control P, bone relative. This one here. Grab here, Control P, bone relative. So all these things are now paired. And I think you'll see that if you were to move this joint around now, everything would move except for the model because we haven't paired it yet. Okay? So let's save here. And I highly recommend, by the way, that you save out your models separate, you know, the models and geometry separate from the Phobos part of it, because if it crashes and you have all this joined, you have to go through a lot of hassle to reset it back to the way it was. So I'm saving this under robot Phobos.blend, and the other one is just robot.blend, I think. So just a tip. Now what we need to do is pair the geometry to the links as well. So what we're going to do is click on the body part and then shift click the link, Control P, and this time instead of bone relative we're going to do object, keep transform. And that's going to, now if we look in our menu here, in our properties menu, you can see now we have a visual, we have a joint, we do not yet have a inertial or collision. We'll get to that in a few minutes. So we did that. That was the body. So let's do the wheel. Click on this, shift click this one, Control P, object, keep transform. And then if we click on that joint, you'll see over in your object information, we now have a visual of wheel right. Okay. Click this one, shift click the link, Control P, object, keep transform. Click on the caster, shift click its link, Control P, object, keep transform. And the same thing with the last one. Shift click the link, Control P, object, keep transform. Great. Now you'll see that if we were to if we were to grab that middle link and move it, now everything moves, right? Great. Save it there. Now, what we're going to do is we have to tell, you see down here there is it doesn't know what kind of geometry these are. You'll see there's no property information here, and if you were to try to export a model from here, you're going to get an error because it doesn't know what kind of geometry you're creating, what kind of geometry you're linking. So what we're going to do is I'm going to use this define geometry. You'll click on the body, define geometry, and we're going to call it a mesh because that's what it is, and okay. Now we're going to do the wheel. This one will do a little different. It's a primitive, it's a cylinder, so we can say define geometry. Instead of mesh, we'll say cylinder, and okay. Same thing with this one. Define geometry, cylinder, okay. Now for this one, this is a little more complex. We could technically do a sphere, and it would probably be more efficient and all that. I'm just right at the moment going to call it a mesh. So define geometry, mesh, and okay. And the same thing with this back one here. Define geometry, mesh, okay. Now you'll see in the property information the material that we assign to it, gray, and it is a caster of type mesh. All right. Now we have to create collision objects. Right now it's pretty close. But we need the last two things we need are collision objects, and we need inertial objects. Okay, inertial properties for each thing. That's kind of tough, and we're going to save that for a different time. But in the meantime, what I'm going to do is I am going to take. I think what we'll do is create just empty inertial tags, or base it on the geometry or something like that, and then figure out the mass later. Because you have to know all that stuff. Let's see. We'll do this, and I'm going to create collision object right here. And we're going to make that collision type a cylinder. And you can see it makes a cylinder for me, which is just the shape of everything there. And that was kind of my idea. I'm like, this is going to be its collision, like we're moving a big cylinder around it. It doesn't worry about the components. Now, I'm going to define the geometry for that cylinder as a cylinder, and I am going to pair that cylinder to this in the same way we did before with the other meshes. We just control click, control P, or shift click, control P, object keep transform. And now I think you'll see in the link here, we now have the collision filled out. We have the joint and the visual component of body, and it created this collision object for us, this cylinder. So I think that's going to work well. Now let's see. I'm going to hide this just for the moment because it can be kind of crazy, confusing. We're going to do the wheel next. Create collision object. We'll do define geometry as a cylinder. We'll shift click the joint, control P, object keep transform. Do this one here. Create collision object here. It's a cylinder. Define geometry. We'll define it as cylinder. Okay. Shift click this. Object keep transform with control P. All right. These are, again, I'm just going to say these as meshes. Create collision object. Caster. Define geometry as a mesh. Okay. I don't know why it's the collision object here should be. Let's try that again. Do this. Create collision, or actually, we'll do it this way. I'm going to Shift D to duplicate that. Well, or not. No, I guess we'll use a primitive to, for it then. There's no reason not to, I suppose. Create collision object. Let's see if we can do a sphere. Except it's huge. So we want to scale it down. And move it up a bit until it's... In fact, we can try to click it right on the bottom there. Okay. So that's it. And then we define the geometry as a sphere. And then shift click the link. And control P. Object, keep transform. This, create collision object, scale it down. I suppose I could have copied the other one, but no matter. There we go. That's just fine. Define geometry as a sphere. Hit OK. And then shift click the link, Control P, object, keep transform. Now, up here you see we've got the collision all together in here. Let's enable the body real quick again and save real quick. Now we've got the link body. Let's take a look here. We've got collision, joint, visual. And now if we click create inertials and just leave the mass at 0 for now, hit OK, it's going to create my inertial properties. Now we can go back and mess with these later. And this is the mass up here based on, you know. But we can figure out the mass of a cylinder, you know. Wikipedia has all of the formulas on how to do this. Okay. Let's check the other ones. This one is also caster. It's got a collision object. Let's calculate or create inertials. Okay. So now we've got inertials. So all of that's all filled in. Let's look at this one. This one's got everything except inertials, so let's create inertials. Okay, and that's all filled in. This will just go as blank, you know, as zeros in the URDF, which is good. This needs inertials, create inertials, 0, there we go. This one should probably already have inertial body link. This one, probably not. Let's see. Create inertials. Okay, and there they are. So now all of them have the things, everything that's needed to create our URDF, as far as I can see. Okay. And hopefully there's no errors. Let's save. Here's the big moment. We'll center this all up. Hit A to select all. And we'll check it down in here. Now there's some meshes that need to be exported. So we're going to click URDF, which is what the model is going to be. We'll make them STLs, and the link will be an STL. File will be relative. We're going to name the model. We'll name it My Robot. How's that? Original. And there it was named. This path shows where the thing's going to go, and you can mess with this later. We're going to end up taking all this stuff and putting it in a different folder eventually anyway, so it doesn't really bother me where it goes at the moment. You'll need to know later, though. You'll have to modify the paths when it gets put in a different folder in a project, actually. So here we go. Let's export the model, and it thinks about it. And let's see if it worked. We'll go into Files, 3D Models. Okay. And in here, we have our robot blend here. And the STLs, that's where everything went. So let's look at our desktop here. And on the desktop, you'll see we now have, because it was a ... you'll see that these went to the desktop. So here is the URDF, My Robot. Okay. And inside of that, we've got our XML document. It has all of the link body, link caster back, caster front, link wheel, link, and then the joint. The links and the joints are all together. You can see it has the origins. It even has the file names for the meshes and where it points to. Those are the things we'll probably have to modify later. It's got the colors, the type of joints, and I think that if we look in the meshes folder, and there's an STL folder, and in there we'll see caster ball, and then cylinder, of course, is the big, our big body part. It just named it cylinder for some reason. I think it's because it was the inner geometry that it was looking at, the very first thing it picked up. So I think we've done a good job, and we have our document, and that's all for this video. I think we'll carry on with this. Next we'll start, I've already started printing these parts, so I think what we'll do is I'll kind of do videos on the side of what I'm doing with the parts and putting the parts together, and we'll install ROS on the development machine, ROS 1, and put it together. Keep going from there. So we'll see you again.